Good evening, everyone. My name is Saida Said, and I'm a third year PhD scholar at IIT Roorkee. Um, this is a recording as opposed to the live sessions that we are um, used to having because unfortunately on the 19th I did take a live session, but I forgot to record the live interaction. So I am redoing the session for uploading for students that were not present in the session. So let us begin then. Okay, so this is the week 4, and let us first recapitulate what we have studied in week 4 in the um, class in the NPTEL session. So we have okay. So these are the slides for week 4. Let us go through them. So basically, what we will be doing in this session is about settlement. This is about settlement. This week was about settlement. So some introduction on MAT foundation, a summary of shallow foundation. If you remember, we have already discussed questions based on Terzaghis bearing capacity theory. We have discussed these shape factors for this particular theory for square footing, circular footing, for strip footing. Okay, ultimate bearing capacity or cohesionless. These are different cases of the same theory. And we have also talked about, we have also solved a question that details on the effect of water table on bearing capacity. We then discussed a question based on Meyerhoff's theory, effect of shape, depth, and inclination factor. We did some questions based on that. We talked about eccentricity, eccentric loading, inclined loading, and eccentric loading. We did a question on that. We did a question on one-way eccentricity, and essentially we did not do a question on two-way eccentricity explicitly, but as I mentioned in the class, two-way eccentricity, it just means that in one-way eccentricity there will be one effective dimension, reduction in one dimension to an effective dimension because of eccentricity in one direction, and in two-way eccentricity this reduction will be in both the length as well as the breadth. So you will have a B dash as well as an L dash. B dash L dash, your effective area will be B dash L dash, and these are the values that you will be using in finding out the shape factors. Now, if you want me to do explicitly any question on this, please let me know in the discussion forum, and I will, in the next session, I will take up a question on two-way eccentricities. Otherwise, it is more or less same as one-way eccentricity. Okay, so this was the first lecture, and then this week is more about settlement of foundation. Okay, so this is the elastic settlement. This formula is for elastic settlement, usually in cases of sands. So we will be doing a question on settlement of foundation based on this. Um, this is Schmertzmann method. So we will be doing a question based on Schmertzmann method. Then further there is a question that you have solved in class. That is nice. Then the next thing that we will do is there are two questions that we will tackle. One is for Schwartzman method, and second is for normal consolidation settlement for fine-grained soils. So this is what you have studied in this week. Settlement of foundation. Okay, so that is it. So, based on the content of this, the lectures from week number 4, we will be conducting, we will be solving two questions. One is for Sportsman method, one is for the not consolidation method. So as you can see, this is already solved because as I mentioned that I had already uh, done this, I had already conducted a lecture and I will be doing this again. Okay, so there are some things that I have forgotten to mention in the question itself, but the load Q is 150 kilonewton per meter and the depth of foundation is 1.5 meter. Okay, so let us start solving this question. Let me refer to the formula sheet. Give me a moment. Okay, so let's draw the plan of the foundation. The foundation is 2 meter by 3 meter. And what we are given is that gamma equals 18 kilonewton per meter cube, and this is the QC profile that has been provided. And if you can see from here, there is some relation about how we can estimate the ES from QC given. So this is given for a square foundation while we have a rectangular foundation. So what we have to do is we have to calculate for the square foundation and then convert it to the rectangular foundation. So let us draw a table. Let us draw a table. Okay. Let me remove all the scribblings from this page. Let me even remove this from here. Okay, so let us draw a table that has how many rows? we need a row for our depth, we need a row for QC, we need a row for E square, then we need a row for E rectangle. So let us column, sorry, and I think we have three values. Let us, okay. This is our Z, this is QC, this is E square, and this is E rectangular. This is, let us actually write H here. Let us, because we already know the Z. Z is 0 to 5, 0.5 meter below the base of the foundation. See here, Z starts from here. The Z will start from here. Okay. So our H in this case is 0.5. In this case, it is 2. And in this case, it is 2.5 meter. Let me mirror this here. 2100, 3500, and 3000. So E square is 2.5 QC, which comes out to be 2.5, 2100, 5250, 3500 into 2.5, 8750, and 3000 into 2.5, 7500. Now let us utilize this formula and get the corresponding E values for our rectangular foundation. Um, okay, so this is 1 plus 0.4 into log to the base 10. L is 3, B is 2. Actually, let us do one thing. Let us calculate this particular part of the term and then multiply to the whole table. 1 plus 0.4 log L by B. So this comes out to be, let us use more as many significant digits we can because we don't want errors to accumulate. 1.0704, let me write 365 even. Okay, 04. So let me multiply this 1.070. I think up till here is fine, but just so that nobody gets a different answer while doing it in a calculator, that's why I've copied all the significant digits that I could see on my calculator. Let's multiply. So we get approximately, this will be 5620. This will be 8750. This will be 9366. And this will be 7500 8028. Okay, so we got our E values. So let us first discuss what is it that we are doing in the Schwarzman method. Okay, so in this method, see, if you take any book from for a shallow foundation, especially by authors that have done significant work in this area, you will find that there are tons and tons of equations and um, methods and some factors that people have modified over time. You will get a lot of data on this. So there are some methods that have struck out. And yesterday when I was teaching, I used a method from Schwartzman. It was a modified method, but it was pointed out to me that we have done a different method, not a different method, a little bit different from what was taught in the class. So I have now resorted to teaching what was taught in the class. Otherwise, I was referring to BM Das for foundation engineering. So that is that. So in Schwarzman method, what we get is we check, we take an, oh, sorry, strain influencing factor. What we do is we assume that below this foundation, the most of the settlement or uh, most of the effect of the load of the foundation will be obviously at this area. You see, we used to draw those pressure bulbs, something like that. So there is this diagram of influence that Schmertman has given with Z. There is an influence factor value, and whatever we need to do is first we identify the foundation, what type of foundation it is. Is it a square foundation? It is a rectangular foundation? Is it a circular foundation? Secondly, we see the depth. Thirdly, we see for that foundation what is the influence diagram for in this particular case. For example, we got the influence diagram. We plot it on scale till here. We know this value. If it was an XY graph, for example, X and Y, we would know these coordinates. We would know these coordinates. It's x2, y2. We will know this will be the origin, for example, and we will know this coordinate. Y, x will be 0 here. So, okay. And now we have this plane. Now we superimpose our layers over this diagram. For example, this is my strata. It has these three layers. And at the center of each layer, we calculate this Iz value. For this, let me write it in another color. At the center of layer 1, for example, this is layer 1, this is layer 2, and this is layer 3. At the center of this layer, we will calculate the IZ value. This will be IZ1, this will be IZ2, and center of this layer will be IZ3 up to this point, which has already been given by Schmertmann, in which case, in what case, how much we will take will depend on the pre-existing values. Let us now check these values, for example, from the PPT itself. Okay, so this is the influence factor that we are talking about. For rigid footing, the value of I is different, and for flexible footing, the value of I is different. See, when we are taking maximum I and average I, this is exactly what we are doing actually. What we are doing is this. This is the diagram that we get. This is the I max that we get. Okay. So if we have a layer here, 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 and we have a maximum